You know, the satellites orbiting way up above our heads, they represent one of humanity's greatest achievements. They are in so many ways a lifeline that connects us and protects us. But here's the paradox. That very same lifeline is becoming dangerously fragile, and it could threaten our entire way of life.
Think about it. When a disaster hits, a massive hurricane, a devastating earthquake, a terrible flood, and all the infrastructure we count on gets wiped out, satellites are often the only thing left standing. They provide those absolutely critical communication links for first responders, letting them coordinate rescue efforts and save lives when everything on the ground has gone completely silent.
But that's a pretty chilling thought, right? We've built this incredible safety net in the sky, but in doing so, we've also created this new, totally invisible vulnerability. So what happens when the very system we designed to save us is the one that actually collapses? Okay, so to really get a handle on this risk, we've got to first appreciate just how deeply we depend on this lifeline. Because the need for satellite communication, it isn't just a convenience anymore, it's a rapidly growing necessity. I mean, just look at the numbers. The sheer frequency of natural disasters happening around the globe it's skyrocketing. The annual average has more than doubled in only a few decades. And what that really means is that the moments when we absolutely need that resilient, off-world communication are happening more and more often. This powerful statement actually came from the official review of Hurricane Katrina. See, when that storm hit, it didn't just flood a city. It completely knocked out cell towers, telephone lines, fiber optic cables, the whole shebang. It was a brutal lesson in just how fragile our ground-based systems are, and it made one thing crystal clear. Right, so this is the key takeaway. Satellites are our ultimate backup plan. They provide something called backhaul. Think of it as the big data pipe, the backbone connection that gets mobile networks back online. They make sure hospitals stay connected, they can reach remote communities that have no other links, and they deliver that real-time info that helps manage a crisis and, reduce the human cost. So because this tech is literally a lifesaver, it's kicked off this massive, unprecedented boom in satellite deployment. But this incredible expansion, this new orbital gold rush, has created an entirely new kind of problem up there.
And the real game changer here is something called a megaconstellation. We're talking about companies like SpaceX with its Starlink system, or Amazon's Project Kuiper, who are launching literally thousands of small, mass-produced satellites. What's the goal? To blanket the entire globe in high-speed internet and grab a piece of a potential trillion-dollar market.
The scale of this is it's hard to wrap your head around. Right now, we have over 14,000 active satellites up there. But that number is projected to absolutely explode. If all the planned constellations actually get launched, we could be looking at over 50,000 satellites by the end of this decade. Low Earth orbit is getting incredibly crowded. And all this crowding has led researchers to come up with a really specific and honestly pretty alarming metaphor. They call it an orbital house of cards. And that image really tells you everything, right? It's a system that looks stable on the surface, but it's so structurally vulnerable that a single disruptive event could bring the whole thing crashing down. But it's not just a metaphor. Scientists have actually come up with a way to quantify that vulnerability. They've created a metric that acts like a ticking clock, measuring just how close we are to the edge of disaster.
It's called the crash clock, and what it does is it answers this really terrifying what-if question. If some major event happened that instantly knocked out every satellite's ability to steer itself and dodge other objects, how long would it take, on average, for the first major debris-creating collision to happen?
Okay, let's put some numbers to this because this is where the picture gets incredibly stark. Back in 2018, before this mega constellation boom really took off, the crash clock was at 121 days. Pretty comfortable. Today, with thousands more satellites zipping around, that clock has shrunk to just 2.8 days. That is a more than 40-fold increase in risk. It's why satellite operators are now dealing with thousands of collision alerts every single day. Just think about that. 2.8 days. In a widespread crisis where nobody has control, that's the average time until the first domino falls, creating a cloud of high-velocity junk that just makes the problem exponentially worse. And get this, there's even a 30% chance of that collision happening in the first 24 hours.
So the big question is, what could actually trigger this? What's the one event that could knock over that first card in our orbital house of cards? Well, the most likely culprit, it's not from Earth at all. It's from the sun.
We're talking about something called a coronal mass ejection, or CME for short. Think of it as a massive solar storm, a huge blast of energy and charged particles that gets hurled out from the sun. When a really powerful one is aimed right at Earth and hits our planet's magnetic field, it can be absolutely devastating for satellites, basically frying their electronics and cutting off all communication with the ground. Okay, so let's walk through how this nightmare scenario could actually play out, step by step. First, a powerful solar storm hits. Then, thousands of satellites are disabled all at once, becoming these uncontrollable zombie objects. At that point, with no one able to perform collision avoidance maneuvers, that 2.8-day clock starts ticking. Then, a collision happens, which creates thousands of new pieces of debris. And that debris then hits other satellites, creating even more debris. It's a chain reaction. It's known as the Kessler Syndrome.
And look, a Kessler Syndrome event, this isn't some abstract problem just for rocket scientists or space agencies. This would be a catastrophe with immediate devastating consequences for every single person on Earth.
The fallout would be absolutely devastating. In the short term, you'd see supply chains just grind to a halt and navigation systems would fail everywhere. But long term, we could be looking at a global recession and literally losing access to orbit for decades, effectively trapping us here on our own planet.
And let's bring this right down to your daily life. What would this actually feel like? Well, the GPS on your phone would just stop working. Financial markets, which depend on these hyper-precise timing signals from satellites, they could seize up. We'd lose our best tools for forecasting the weather. Mobile networks and global internet, which are now so reliant on that satellite backhaul, would face massive outages. So much of what we call modern life would simply stop.
Okay, that whole scenario is, well, it's terrifying. But it's not a done deal. It doesn't have to happen. We are now in a race against our own technology to figure this out before the worst happens. So what can we do? Well, there are a few big ideas being thrown around. We can enforce super strict rules that say all satellites have to be brought out of orbit within 5 years after their mission is over. We can develop things like space tugs to go up and actively remove junk. We desperately need a global air traffic control system, but for space. And maybe, ultimately, we're going to need binding international treaties that put hard limits on just how many satellites can be launched in the first place.
But here's the kicker, and the research is brutally honest about this. What we're doing right now just isn't cutting it. Relying on voluntary guidelines and just hoping that companies will regulate themselves has proven to be, in the words of the experts, manifestly inadequate. The expansion is just happening way too fast. And so it all comes down to this one single question. We reached for the stars to build a system that could save us in our darkest hours. The challenge now is to find the foresight and the global cooperation to manage this incredible resource, to make sure that our greatest lifeline doesn't become a permanent cage of our own making.